All right, hey, let's go ahead and solve these. I'll start with this one just because I have room to work. Okay. Remember, you pick an equation, your choice. I look at both these. They look about the same to me. I don't see a real advantage in using one over the other. So we'll start with the first one. Let's solve for x. I'm going to add this to both sides. Now, as far as how you format this, there's no one particular way. A lot of times I'm just constrained by the board I'm working on, or maybe the paper you're writing on. So I'm going to take this equation here and write it over here. If you want to write it somewhere else, that's fine. So there is no one, a correct way to write this down. Let's add 1/3 y to both sides. So we will get, where am I here? So 1/2 x. There. I'm going to add this to both sides. So equals 1 plus 1/3 y. And then we'll divide both sides by 1/2, multiplied by 2. And that'll give us, okay, so again, you do math on the first step, but it's not a lot. Like if someone said to me, can I use a calculator? My initial response would be, for what? I'm not really super clear what you'd be using it for. In other words, it could be a sign you're doing something wrong. Now let's make the substitution. This gets substituted in for x right here. So we'll have 3/5 times 2 plus 2/3 y plus 1/2 y equals 2. I'm very close to getting this board mounted on the wall, believe it or not. And then it won't wobble and I'll be able to write a little bit better. One equation, one variable y. Let's solve for y. Let's do the good old distributive rule. So 6/5 plus, I was going to write 6/15, which is correct, but hey, let's reduce fractions and try to make things a little bit easier. Plus 2/5 y plus 1/2 y equals 2. Let's see, is that still visible? Yeah. Let's combine like terms. Let's add these two together. So 9/10 y. And let's subtract 6/5 from both sides. Oh, that's a 2. So we'll get 4/5. I have enough room to put it all the way down to the bottom. Okay, so y equals, let's go ahead and flip and multiply. Maybe your brain feels tired, or maybe my brain feels tired. It's all right. Hey, like I said, show work. It's not a right or wrong thing. It's a really judgment call of what you think is easier to do. Okay, that goes in there once, that goes in there twice, so we get 8/9. So y equals 8/9. At this point, again, like I said, you can substitute this back in any equation. The first equation, second equation. A lot of people like to substitute it in here, and I'm cool with that. In fact, a lot of times it's pretty convenient, so let me go ahead and do that. You'll get the same answer regardless of which equation you substituted in. So 2 plus 2/3 times 8/9. What does that give us here? Did I copy everything down right? Hey, it's easy if you haven't noticed to just make a typographical error. You get a wrong answer, and it can drive you crazy. I won't even go over the ways in which that can happen, but it can happen, and it's ridiculously easy. So what do we have here? 2 plus 16, yuck, over 27. I mean, it's not the end of the world, but it still feels kind of yucky, right? So 54, 64, 70, 70? Okay, so x equals 70 over 27. This is perfectly fine, but even I went yuck. Okay, fine. I mean, 70 and 27 are not horrible numbers, but it may still make you want to say yuck. Okay, so there's that problem. Very typical, classic problem. You see this in science and engineering, economics, all the time. Somebody asked me one time if I own an independent pet store, will I need to know how to do this? And my answer was, no, I don't know. I can't imagine why. But there are many, many uses, and we're going to be going over those shortly. But right now, I just want to get the mechanism down for doing this. This one here, hey, just for fun, we'll start with the second equation. Just for fun, we'll solve for y. So let's add 2x to both sides, 9 plus 2x. Let's divide both sides by 3. We'll substitute. Hey, remember when you do the substitution, you don't do any math. Don't add, subtract, divide, multiply. Don't do the distributive rule. Don't combine like terms. just copy everything down really carefully. And that applies to me too. So let me write this over here. 7x minus 2, what is y equal to? 3 plus 2/3 x. 3 plus 2/3 x equals 11. We're off and running. One equation, one variable. Let's do the distributive rule. 7x minus 6 minus 4/3 x equals 11. Let's combine like terms. 17/3 x. Let's add 6 to both sides. Plus 9. Wow. What? Oh, I wonder if I planned this one to come out nice. Oh, that's right, I did, didn't I? I'm trying to remember. At any rate, the answer here is 3. When the answer comes out as a whole number, it's almost certain that someone planned this on purpose. It's very, in a way, it's very, very artificial. It's not natural that this would happen, but you do see it a lot. I hope you're flying through a lot of practice problems in the book. The book has a lot, and there's a reason for it. Because this single-handedly will give you a quantum leap in your abilities to do algebra if you do a lot. Again, I'd like you to do them all. That may be unrealistic. I don't know. The author thought that was about the right amount to put in there, but you'll have to decide. Hey, x equals 3. Let's go back to the first equation here. 7 times 3 is 21. Minus 2y equals 11. Let's subtract 21 from both sides. Negative 10, and y equals 5. So y equals 5 and x equals 3. Okay, now, what phrase or, what could you say in a math class to make people really have an anxiety attack? Word problems. And yes, we're going to do some word problems. What really drives people mostly crazy with word problems is they don't have the proper skill or method or tool to solve the problem. If you had to change a flat tire and you had nothing but your bare hands, can you imagine how horrible that would be? I mean, it's bad enough as it is, but if you didn't have any other tools except your bare hands, you would think, this is impossible. How can anybody do it? And that very much applies to word problems. People try attacking word problems and they don't really have the tools or the methods to solve them. For our purposes and for a great number of purposes, what you need is to know how to do this. 2 equations and 2 unknowns. So let me show you. I could pick from so many different types. People want to know what types are there. There are an infinite number of types. So, I can't say, hey, here's a comprehensive list of every type of word problem which can be solved with 2 equations and 2 unknowns. There's no such thing. However, there are some classics. And, I'm just trying to pick out which classic I want to pick right now. Well, let's do like maybe the uber, the epic, the ultimate classic. A train leaves a station. Hey, you don't like a train? Make it a car, make it a bike, make it a plane, walk, swim. What I need is an object which is moving in a straight line for now, maybe for the rest of this course. But we need an object to leave. So let's just say a train leaves a station at 12 p.m. Now I could have been really evil and annoying, and I could have said, well, it was 11:32 and 24 seconds. The method I'm going to show you now will work with that too, no problems. There's just no reason to make the numbers unpleasant. So for the first example, I want to make the numbers extremely easy because the method will be exactly the same. And this train, let's say this train is traveling 40 miles per hour. I could have had the train traveling 83.29 miles an hour. Again, the method I would use to solve it is the same. We'd have to plow through horrible numbers. So let's just stick with the easy numbers. Meanwhile, as I reach for a different colored marker, let's say the red train, and the red train, let's just say it leaves at 1:20 p.m., and this train is traveling 60 miles per hour. The classic question is, at what time will they meet? And how far from the station will they be when the faster train catches up to the slower train? Now, there's a whole lot of ways to solve this. This is a case where I'm going to use 2 equations and 2 unknowns. And why? Because it's by far the easiest way. I mean, I don't think there's any comparison. I mean, if you want to use a different method, go ahead. But I'm telling you, this is not only the easiest way, but it lays the groundwork for you being able to solve all kinds of other word problems, not just a train leaves the station problem. Now, for a lot of word problems, and this one especially, there's a governing equation, which you need to know. I wish you were all here gathered, because what I would ask you right now, or I'll ask you right now, who does not know the definition of velocity? Now, think about it in a classroom setting. A lot of people raise their hands, some people wouldn't. Some people know the answer, but they don't want to get involved, so they don't raise their hand, and it goes on and on and on. But I would just like to honestly know who doesn't know the definition of velocity. So suppose, some number of you raise your hand, and I would say to you, you do know, because all of you know. You're in a car driving down the road, you see a speed sign. Hey, what's the speed limit? 65 hours per mile. If I said that, or anybody said, what did I just say, hours per mile? People will look at you like, what? Hours per mile? What are you talking about? Oh, miles hours. You go, what? What? Everybody's heard of, what did I just say? Hours per mile? Miles hours? Wait a minute. Miles per hour, or kilometers per hour, or feet per second, or meters per second, fine. But miles per hour. Everybody knows miles per hour. So velocity is miles per hour, or miles is a measure of distance, and hour is a measure of time. At which point I see everybody writing this down, and I feel like, well, you missed the point. If you know miles per hour, if that's something you know, then you know this. You know it already. It would be like me asking you what's your name, and you say Fred, and then you copy it down in your notes. That would be weird because you know your name. Don't know why you're writing in your notes. Hey, if you didn't know miles per hour, or kilometers per hour, or feet per second, or meters per second, or cubits per minute, or however you want to measure this, then write this down. Now, I will admit, this is maybe not the easiest form of this equation to use. Let's solve for d, okay? Let's multiply both sides by t, and you get distance equals v times t. This is a slightly easier form of the equation to use, at least for our purposes here. Do I have this memorized? Me personally, I mean, honestly, yeah, I do. I couldn't help it somehow or another over time. This got stuck in my head. However, how long does it take to go from here to here? 1 second? 2 seconds? This is something that is just, it's seared into my brain. I can't not know it. Miles per hour. I mean, how can I not know that? To get from here to here is 1 second. So even though I have this memorized, I see no reason whatsoever to memorize this. Okay, that said, let's apply this to the two trains. How far does the first train travel? We do not know. What's the velocity of the first train? 40. How long will the first train be traveling for? We don't know. What about the second train? How far will it be traveling by the time it catches the first train? We don't know. What's its velocity? 60. How long will it be traveling for? Well, it left later than the first train. So it won't be traveling, it will not have been traveling for as long. So it will have been traveling for a time equal to t minus, was it left at 120? So t minus 4/3. This would be a perfect example. I'm going to talk about something that a lot of teachers wouldn't. For a lot of teachers, if you said where the 4/3 come from, they would just give you a funny stare, like what? Like that's a silly, ridiculous question. In a way, it is, except it shows how fractions are going to keep coming up and they keep haunting people. I don't mean everybody, and so if you get the 4/3, fantastic. The train left at 1:20. That's 1 hour and 20 minutes, which is 1 hour and 20/60ths of an hour, 60 minutes in an hour. This is 1 hour plus 1/3 of an hour, which is 1 1/3, which is 4/3, and that's where I got that from. We don't want to mix hours with minutes. We don't want to mix hours with minutes. What do we have here? Two equations and two unknowns. So if you know how to solve two equations and two unknowns, this problem is done. This is as good as done. We still do have to finish it. So let's go ahead and polish that off. This is already solved for D. Let's substitute in for D there. 40t, let's go ahead, excuse me, get the ball rolling, do the distributive rule. 60t minus 80, subtract 60t from both sides, negative 20t equals negative 80, and divide both sides by 20, and you get 4. So 4 hours. So the first train will have been going 4 hours. So fine, they meet at 4 p.m. And like any two equations and two unknowns, take this and substitute it back in there. So 40 times 4, 160 miles, 4 hours. So there we go. Now, moving forward, every once in a while, I'm going to talk about something that would, roughly speaking, fall into the category of history of math or philosophy of mathematics. And you're only going to get that on these videos. So hopefully you're watching this. And I may put either bonus questions or some questions. I'm not going to make them worth very much, but on the next test and the following tests, where you'll be able to answer it just by, either remembering or you can review a video or what have you. So one question is why there's 60 minutes in an hour. I've been meaning to look it up. Maybe I'll look it up right now. Why there are 24 hours a day. I don't know where that came from. But the ancient Babylonians, and if you don't know anything about the ancient Babylonians, Google ancient Babylonians. They lived in Mesopotamia, modern day Iraq region of the world. And they determined, this may not seem like a big deal, but I suggest you stop and think about it for a minute. The mere fact that time is cyclical, that there are years, that is not obvious. Your pet dog or cat or a 2-year-old child does not know what you mean when you say, hey, what were you doing last year at this time? Or what are you going to be doing next year at this time? That question doesn't make any sense to a 2-year-old, or probably a 3-year-old. I don't know what way it starts to make sense. But the mere fact that time has cycles or periods is not at all obvious. At any rate, the Babylonians divided time into years, and they determined that there were 360 days in a year. Hey, they were off by a few days. Not bad for 4,000 years ago, 1800 BC. Now, for reasons I couldn't tell you why, except they felt 6 was kind of a magical number. They took 360 and divided it by 6, which is 60. They used that for the base of their number system. Oh, why do we have 360 degrees in a circle? Thank the Babylonians. I guess they felt time was cyclical, like a circle. They counted 360 days in a year. So that's why we have 360 degrees in a circle. Divide by 6, I guess just for mystical reasons. They got 60. They use that for the base of the number system. Very awkward, cumbersome nonetheless. That's what they did. So they had 60 symbols. That's why we have 60 minutes in an hour. And then in modern times, I think it was probably in the 1700s. We'll have to look it up. Plus or minus a century. Once we had more accurate clocks. The minute wasn't a fine enough subdivision. So if you create a second subdivision of the hour, so the first subdivision were minutes, the second subdivision, divide by 60 again, you get seconds. That's why there's 60 seconds. And minute, that's why we call it seconds. It's a second subdivision of the hour. So we could come up with, and people have a metric version of time. Time's really hard to grasp intuitively. If you look at kids when they're in their early years, they don't really get time. How long has it been? 5 minutes, 5 hours. It's not easy. So once you've acquired an intuitive sense of time, I guess nobody wants to change it. Probably in a few weeks, if not just a few days, but here in the near future, I'm going to very carefully go over the metric system, and I will be testing you on that. Now, this bit about 60 minutes an hour, that's probably like worth a bonus point or extra credit or something like that. Nonetheless, I'm going to start mentioning some things along those lines as we go along, if for no other reason than I really want you to watch the videos and practice these problems. So this is sort of the classic train leaves the station problem, and coming up next video we'll do lots of other yuck, I hate to say it, but word problems, or applied problems, or practical problems, or real world problems. Okay, hey, enough for now. See you next video.